Hey everybody, welcome back to the Drones, the Dawn of Drones podcast. I can't even remember the name of my podcast. It's been a morning already. I'm Dawn Zoldi. I'm the host, and I'm also the CEO of P3 Tech Consulting. This is live, so please join us in the chat. Tell us where you're coming from. Ask us some questions. Give us some positive encouragement. We absolutely love that. We are about 3/4 of the way through Innovation Month, sponsored by Iris Automation. So thank you again to Iris. We've had some amazing speakers. And so if you missed any of those episodes, go back and watch them on demand on DroneLife's Drone TV YouTube channel. So you can absolutely check that out this month and all of our back episodes. It's funny, Jack, because we talk about Innovation Month, but I feel like this has been Black Swift Technologies and Dr. Jack Elston kind of 60 days, is definitely more than a month. Everybody, if you didn't know, I just want to talk for a second about some of the things we've done with Jack. You can go back and watch. First, we did have him on our clubhouse there called UAS Colorado Chats. We do that every Monday, the last Monday of every month at 11 a.m. Mountain. So if you're not on Clubhouse, you should be. It's awesome. Join our club, follow me there. We didn't tape that, but we did tape last week, Jack, on our UAS Colorado meetup. You can check that out on the UAS Colorado YouTube channel. We talked all about his, he talked all about his volcano research. We're going to talk a little bit about it here, but it's really expansive on there. So absolutely check that out. Last week on our Drone Law Connections Clubhouse, we had, which is every Thursday at 11 a.m. Mountain, we had Jack's co-founder for Black Swift, Dr. Maciek Statura. I'm sure I'm still butchering his name. It's like a lot of vowels, and he's amazing. And now here we have Jack on our podcast, and what a privilege, Jack. So thank you so much for being here with us today.
Yeah, sure. Happy to be here.
And so tell us a little bit about your background, your educational background first, and then we'll talk about, kind of how you created Black Swift.
Sure, sounds good. Yeah, I met Maciek actually at a research lab at the University of Colorado. We were doing work with unmanned aircraft systems on all sorts of different applications, everything from mesh communication networks over multiple different aircraft to doing atmospheric science.
So, okay, so you talk about meeting Maciek, but tell us about yourself. So you have a PhD. Tell us a little bit about your educational background.
Sure. I started out at the Naval Academy. I really wanted to be a pilot. Unfortunately, my eyesight wasn't good enough, so I got medically disqualified. Transferred to CU because it was in state and didn't really have too many plans from there. Ended up kind of getting involved with a senior project group to design an avionics system for doing wildland firefighting, and really kind of grew a passion for working with unmanned aircraft systems from there. Also discovered I could go skiing while doing research, and so those two kind of paired up nicely for me to stay for quite some time at CU and then eventually get my PhD doing a really interesting project, basically tornado chasing with unmanned aircraft systems.
Jack, I don't know how many times you and I have talked, and I had no idea that you were at the United States Naval Academy. So for what it's worth, my eyesight is likewise horrible. And when I joined the JAG Corps, the Air Force JAG Corps, and I tested, at that MEP station to get entry into the Air Force, they were like, you have zero depth perception. You will never be a pilot. So I can completely relate to that. So interesting. Every time I talk to you, I learn something new. And obviously Jack's talking about Colorado. Props to the state. If you want to come out here, ski and fly drones and work with some amazing people like Jack, this is absolutely the place to do it. So I'm glad that you found Colorado and you found your home in Boulder. We're all benefiting from that. And the fact that you met Maciek during your graduate and postgraduate studies, and then the two of you created the company Black Swift. So tell us all about Black Swift Technologies. what was your inspiration for it, and what you guys are doing now?
Sure. And while doing research at the University of Colorado, we're using a lot of old DoD heritage autopilots. They're relatively expensive. They're kind of hard to set up, hard to operate, and so we felt we could do a little bit better job as far as giving people something they could use commercially to get the aircraft out of the way so they could go get their data. So literally started in my living room by building electronics, testing them out, and then ended up getting a couple of customers to integrate our system with their aircraft. They really kind of put us through our paces. It was kind of fun doing that. One of the guys, a local guy, actually was a competition glider pilot. He's ranked nationally as far as some of the best in the world. And what he had us do is integrate our autopilot system with his aircraft, and he put it through its paces. He'd flip it upside down and turn it back to the autopilot, or put it in a power-on dive and put it back to the autopilot. And we'd never really tested all those cases before, but we knew the math was there. So it was just kind of nice to actually see it work the way it was supposed to. And the fortunate thing is after that, he was so impressed that we got a bunch of different sales out of that opportunity. We ended up kind of realizing that there was a lot of support work going along with installing autopilot systems, and so we were losing a lot of our margin to that. So we took an opportunity where we got some funding from NASA to develop our soil moisture sensor to kind of build an aircraft around that sensor, kind of a unique way of looking at the design space. But that sensor's so sensitive that it actually requires a lot of different care as far as electromagnetic interference, payload space, and so on and so forth. And so that's eventually what became our S2.
So you started out, as you said, kind of, I think Maciek actually in the clubhouse said the two of you were building stuff in your kitchen, much to the chagrin, I think, of your wife at the time. And
Yes.
and so I didn't know you started out testing an autopilot on manned aircraft. Very interesting. Tell us a little bit about the soil moisture sensor and how you incorporate that into drones. It sounds like that's kind of how you kicked off the company, maybe, in
Sure.
earnest?
To clarify too, he was a remote control glider competition pilot.
Got
So
it.
it wasn't.
Okay. All right. Got it.
Yeah, we had a lot of experience writing proposals and things like that through the university, and so ended up putting in a proposal for what's called a Small Business Innovative Research Grant with NASA to convert a very large radiometer, something that had flown on manned aircraft but never really on a small unmanned aircraft, shrink that down, add a bit of new technology to be able to accommodate a lot of the different stuff that goes on with unmanned aircraft systems, and be able to fly over a field and just tell you how much water's in the top level of the soil.
So I imagine that's huge for precision agriculture. So who's using this today? And you said it's the S2, right? That this kind of became your S2 aircraft. And I know you've got several different designs that you've created in-house at Black Swift. So tell us a little bit about the S2 first, and then we'll talk a little bit more about the precision ag.
Sure thing. Yeah, the S2 is a 10-foot wingspan composite aircraft. It uses a pneumatic launcher and does belly landing, mainly so we can lose a lot of weight and keep it up in the air for as long as possible. It's battery powered. We don't want an internal combustion engine when we're doing atmospheric sampling and things like that to kind of pollute what you're measuring. And the nice thing is it all packs down into a very small case that you could take on board commercial airline. So that if you need to be responsive to an event like a wildfire, a volcano, or something like that, it's easy to just take with you and just go start doing observations. We designed it in such a way that you don't need any sort of improvements where you're operating from. You don't need a runway and things like that. That's very critical for some of these events that go on that you have to be responsive to. And then, as we mentioned, it's unique in the fact that the payload space is very quiet as far as radio interference, and it's a very large volume for what it can carry. So the vehicle can carry up to 5 pounds of payload, but the space is about 8 inches in diameter, about 2 feet long. It's quite a large volume for actually the amount of aircraft that you're using with it.
I think it was Jack. I don't remember if it was you or Maciek because I've talked to you both, I think, several times now. Like I said, in the last 30 days, but it was almost like you had use cases in mind and you kind of built the aircraft around those instead of the other way around, which, I think it's a unique approach because I think most people are building an aircraft like, all right, now, let's find some things we can do with this. So it sounds like you just mentioned some extreme examples, atmospheric type measurements. But before we get deeply into those, let's go back to the soil moisture thing and talk a little bit about the precision agriculture kind of use case that the S2 is being used for. Can you kind of expand on that a little bit? Like who's using it now, and what are they learning using your S2?
So I mean, developing a sensor from scratch turns out to be pretty hard. I guess it's surprising most people, but so we were just now getting to the point where we're turning it into a commercial product, mostly as a data service, because the instrument itself is actually relatively expensive. But we've been working for quite some time with various different institutions. Just recently got done with the USGS out in California, flying over a technological test bed that they have out there. They call the Pepperwood Preserve. It's in wine country, so very hilly, kind of rugged terrain. And what they were wanting to do is gather soil moisture data to add to the huge record of data they have for that area, but then also take a look at management of the land and figure out how they can better mitigate a lot of the damaging fires that they've had out there recently.
Wow, so the sensor that you also design in addition to the aircraft is being used to help mitigate wildfire or kind of, yeah, I guess prevent, if you will, prevention for wildfires, and being used by the federal government. You mentioned commercial side. I heard the word winery. I mean, I imagine soil moisture and kind of how those things are doing is probably super important to wineries. So it sounds like you've got a pretty great market there, Jack, for that. You know what? As I'm thinking about this, you really probably also need to talk to, if you haven't met Tanner Harris from Blue Nose Aerial. They're doing some interesting things with golf courses, and not the soil moisture aspect necessarily, but maybe there's a good plug in there for the two of you. And Tanner is out of Denver, so hopefully I can match you two up, and that could be some really interesting conversations. They're also doing some precision ag stuff in the cannabis and hemp space, which again, soil moisture could be an interesting additional component to their work there. But let's shift gears a little bit to some of these kind of extreme, let's call it extreme beyond visual line of sight things you're doing. You mentioned kind of starting out with this autopilot, this soil moisture sensor, creating this aircraft, working with NASA. Remind me what your first real kind of, let's call it beyond visual line of sight, extreme use case was, when we're talking about like tornadoes or hurricanes or volcanoes. What was the first, area where you started really getting into that?
I mean, a lot of it is stemming from that research that we did at the University of Colorado with Dr. Brian Argrove's group there. So doing the sampling of these supercell thunderstorms, they produce tornadoes is the whole reason why we're chasing them, trying to figure out why and when they'll produce tornadoes. So what we'd do is we'd set up a ground station in an area we knew was not going to be impacted by the storm, and kind of let the storm sweep by in front of us. So in order to get to the area that we wanted to sample, we had to go, many miles away from the ground station. So that was kind of part of our original, let's say, beyond line of sight, because we ended up actually having to have a chase car underneath the aircraft, but the operations of the aircraft were being done from many miles away.
Now, I remember when we talked about this on Clubhouse, you mentioned this was really, was this before 2016 and before the Part 107 rules?
Yeah, this was in 2009, 2010.
So you had to, as you said, work very closely with the FAA on this kind of research, and as you mentioned, have a chase car here. What were you trying to achieve in this tornadic, beyond visual line of sight research with the drone?
Sure. Yeah, you'd mentioned doing some of the pioneering research for, kind of pushing the envelope with unmanned aircraft systems as far as being responsive to these things. And we have, as part of that campaign, we received Western Service Area COA #1, so I was kind of applied for that one.
COA #1, okay.
As far as the research, though, there's various different components that have to go into these storms and they all mix together, and that's what either makes tornadoes or doesn't. And so we're trying to figure out which components needed to be there in which capacity to spin up the storm. One of the areas that they hadn't had a lot of data from was called the rear flank downdraft, and it's because it's clear air, meaning there's no scatters and there's no rain, there's no hail, there's no bugs. And so radar doesn't bounce off of it, and so they don't have a lot of idea what the winds and what the temperatures are within that region of the storm. you try and put a balloon up into it, it's just going to be taken away very quickly because they're very strong winds there. And it's not really a great place for manned aviation, so it was a perfect use case for unmanned aircraft systems.
So you said it was the rear flank downwind area of the tornado?
Yeah, it's a region called the rear flank downdraft. Basically, you just have various different areas of the storm, updrafts and downdrafts kind of mixing together, and that's where you get all that spinning motion. And so the rear flank downdraft just happens to be a large part of the storm where you've got descending air.
And I remember I want to get into the really weird thing that happened to you when you did those flights, but let's talk a little bit about the fact that it's not just air, right? When you're in these tornadoes, they usually spawn off some pretty serious hail, and obviously rain. And so kind of what you had to do to protect the drone or ensure that it was going to be resilient to be able to take those measurements in that kind of extreme environment. Can you explain that a little bit?
Sure. Yeah, it turns out these small aircraft are surprisingly resilient to hail. That was one of the things that kind of shocked us. As far as rain, that's actually more dangerous to these aircraft than hail, at least in our experience, because raindrops can bridge the pitot tube, so the thing that's giving you your airspeed on the front of the aircraft, and make it so you can't actually measure your airspeed. So you can kind of guess off of GPS and what you used to know the winds were, but it's a very dangerous situation. That's kind of where our biggest concern was, actually having not getting into the electronics, but actually making it so we can't measure how fast we're going.
So for the hail, though, that was kind of part of the automation you programmed into the S2 at the time, kind of a detect and avoid, if you will, to kind of detect the hail and try to dodge that, right, as you were flying?
Well, so this was actually with a vehicle called the Tempest. This was part of CU stuff that we were doing beforehand.
Got it. The earlier edition, yeah.
Yeah, for the detect and avoid at that point in time, the aircraft didn't have a lot of situational awareness of the storm on board. But the FAA, since they had us with that chase car that was underneath the aircraft at all times, they were able to give us visual observations, and then also we were looking very closely at the radar returns, even from the local trucks that we had in the area. So we're getting very up to date information about what's going on with the storm. The hail core is quite apparent. It reflects red air quite well, and so we were able to generally steer the people out of the way of the hail core. And there was one incident where we got pretty close to it, and they kind of got run over. Too bad, just a broken windshield, but everything survived, and it wasn't too big of a deal.
Okay, awesome. Yeah, let's kind of table this discussion of the automation you built into your later edition and the S2 and some of your other drones, essentially in response to the things you learned over time from these extreme VLOS operations you were doing. Let's talk for a second about the rain resilience. You mentioned how significant that can be and how dangerous that could be to the drone. And the ability, did you just say to understand airspeed, or was that? Yeah, okay, so that's pretty significant. How did you try to kind of protect against that in these operations?
Generally, there's two ways that people do that. One's with a heated pitot, so basically you get it very hot, and then it'll boil off any water that bridge the front of that port. Or you can actually change the size of the tube. There's actually a diameter that it gets large enough where the water can't physically bridge that tube. You get not as good of a measurement with those larger tubes, but it kind of protects you against those rain things. It's one of the things we're having to deal with a lot right now when we're crafting tubes.
What was the last part? There was a little bit of a glitch, I think, at least on my end.
Yeah, it's one of the significant things that we're having to do as far as innovation right now.
Okay, yeah.
A wet environment.
Yeah, if you crack that code, Jack, woo, I need to be buying some Black Swift stock right now, because that is hugely significant for all drone operations, not just these extreme ones, flying into tornadoes, of course. I want to talk for a second about that really interesting thing you learned, or that you were surprised to see happen in that downdraft, I think you called it. What happened to the aircraft as you were in there unexpectedly that was something you all learned by doing this?
There are two major incidents. The one was the vehicle itself actually ended up getting up to, I think it was 135-mile-an-hour ground speeds. So you imagine looking up, see a 10-foot wingspan plane at 1,000 feet up from a car, and it's moving that fast. It's not simple. So what we
Wow.
ended up doing is throwing a bunch of sensors in the car itself, actually. And so the aircraft knew where the car was all the time. And we told the aircraft, hey, just go orbit the car when you get too fast. And so that allowed the people in the car to move the center point of that orbit. So it was just out their window, and then they could just stare out the window and easily see where the aircraft was at all times. The other thing that we kind of encountered was, well, we expected there'd be turbulence, and we really designed this aircraft to be robust to it. It turned out the turbulence was on such a large scale that it would just move the aircraft around in the air. So there was one point in time where the aircraft was climbing so fast that it completely shut off the motor, had itself in a full-on dive, and it wasn't getting out of that air mass. And so sitting back at the ground station, I actually had to command it to increase its speed so it would turn on the motor and try and pull itself out of that. And so you could kind of see, like, there's a ton of energy in these storms, and if you get in the wrong parts of them, it can take you somewhere very quickly you don't want to be.
Wow. So were you able to kind of recover that second one that you were just mentioning?
Yeah, before we got too high, I was able to kind of get out of that feature, and then we didn't go back and revisit that again afterwards. And
Oh my
we ended up,
gosh.
over the 2 years, we did 72 different flights and didn't lose a vehicle, so we're pretty happy about that.
I mean, that's a significant accomplishment. I mean, that is huge. And I remember we were talking before, you mentioned like it was a little surprising you're in a downdraft and it actually fired the drone to go straight up, which was maybe something that was also a little bit of a surprise and unexpected. So
We'd ended up crossing into a different part of the storm, so we were sampling across the boundary between the downdraft and the updraft, and well, obviously we were in the updraft very strongly at that point in time.
wow. Wow. So tell us, just from a scientific standpoint, what those scientists learned that's so important to society from some of this research.
Yeah, the experiment was called Vortex 2 because there was an original Vortex, and the original Vortex kind of showed how the radar networks took the estimates of how good we were at estimating when a tornado was going to happen, decreased the false positives, and gave us about a 13-minute heads up as far as when tornadoes were going to happen. That's not a lot of time, but that's better than it used to be, where it's basically just there's a tornado, somebody called it in. And so the whole objective of this was to really throw a lot of instrumentation at these storms to further improve the model and push that warning time out even further to give people a better heads up about, hey, there's storms in the area that are producing tornadoes and we think it's going to be here in, say 20 or 30 minutes.
Well, that's, 20 to 30 minutes. I mean, even 13 minutes, someone on the road or someone that has to kind of get under cover for a tornado, that's really significant. So that's awesome that you were able to do that. So let's talk a little bit about, obviously we talked about some of the safety precautions the FAA had there. Let's transition a little bit to your hurricane research. Because, like I said, I'm kind of coining your company as the Extreme BVLOS, group there. And tell us a little bit about how you got involved in hurricane research and what you were trying to achieve there.
Yeah, so we ended up applying for another one of those research grants, this time with NOAA. And we ended up working with Dr. Josione, who's there. He had previously done a lot of work with flying unmanned aircraft systems into hurricanes. He was involved in an experiment, I think it was back in '94, where they flew an aerosol off the coast of Florida out into the storm and got such great data that they ended up deciding it was worth ditching the plane to just keep gathering data.
Wow.
So from there, he's kind of had a passion to continue to get things into the storm. They repurposed an old DoD aircraft that's tube launched, so it folds up. They push it out of the P3, pops wings out, and then goes and flies down into the storm. Since this vehicle is mainly designed for just returning video, they took the cameras out, put in some thermodynamic sensors, and got okay data. But it didn't, it's not really designed for the hurricane environment. They had some troubles with that. And but they were able to show that they were getting, really interesting information that was able to help them predict, when it was making landfall, where it was going to be, what the speed of the hurricane was going to be at that point in time. And so they put out a call to have companies design from the ground up something that was specific for this application. So better flights in hurricanes, cheaper because those Coyote aircraft aren't very, aren't very cost effective. And then something that has sensors embedded in it that are designed to get winds, pressure, temperature, and humidity.
And so I imagine that your research with the tornadoes was directly relevant to this, between the rain, the winds, the sensors you had already created. So obviously you landed that gig with NOAA, and tell us a little bit maybe about some lessons learned from that.
So the the research is still ongoing with NOAA. We just received another round of funding that was beyond the SBIR effort, so we're kind of into the commercialization phase, I guess, if you call it. As far as putting together these very small purpose-built aircraft, they can be very tricky, cramming a bunch of electronics down to a very small package, and then also keeping that in is expensive. One of the cool things we did, since we're both an autopilot company and a sensor company, is we were able to combine the wind sensing with the autopilot, tightly coupled into one small package. It reduced weight, it reduced size, but it also significantly increases our ability to accurately measure winds, particularly vertical winds, which are one of the harder things to actually get from an unmanned aircraft system.
I'm thinking out loud again. You totally need to be talking to Don Bershoff at True Weather Solutions, because these sensors you're talking about, I think he'd be highly interested in having a good conversation with you about that and some of the work he's doing. So that's really cool. So once again, kind of I know this research is ongoing, but what are you learning so far, if you can share a little bit about that? What are the scientists learning?
From the data from the hurricanes?
From the hurricanes, yeah.
Yeah, they've identified that the sea surface interface, so just kind of like the lower 100 feet of the storm, is one of the critical drivers. I mean, a lot of the energy for the storm's coming out of the ocean itself. And so they can measure sea temperature, wave height, and then just the atmospheric properties around that area. It gives them a very good idea of what's going on with the hurricane, and they can improve their model. And so, out of the original flights that Joe did, I forget, the accuracy improvements that they've shown. I don't have quantification for that, but I mean, they have showed very significant improvements in the forecasting model.
Well, so just curious, I've read articles about seaborne, autonomous vehicles that they're using for some of this. Do your airborne vehicles communicate with those, or does NOAA just use those vehicles and your information from your vehicles and conglomerate that information?
Yeah, right now they're kind of independent efforts. Certainly, I'm sure they'd love to have a coordinated effort between all those different things. Right now, our aircraft reports back to the P3, so it communicates back to the manned aircraft. It can do that for, we're hoping, about 300 kilometers. So the P3 can go and continue its mission while we're flying down in there, feeding back additional information to the P3 while it's making its measurement. So
wow,
way, and hopefully the ground-based, the ocean-based vehicles can also kind of team up, so you can have all that information available in one interface in real time.
Yeah, absolutely. I mean, look, networked is the way, the future, autonomous networked, and I know you're going to be a huge part of that, working with NOAA and NASA and so many other folks. So I'm going to kind of skip over volcanoes, because, like I said, you talked about that so extensively in the UAS Colorado meetup. So I'm going to remind people, go back to the UAS Colorado YouTube channel and check out that video. Jack did a great presentation on that. I want to skip over and talk a little bit about, in fact, I don't know if the picture that was kind of on our marketing for you, Jack, was from the Arctic. But if you can tell us a little bit about your Arctic adventures, that would be really interesting.
Yeah, that's actually one of my places I love operating in. It presents all its own unique challenges. One of the ones I did, I think that picture is actually from a trip to Antarctica. But the one of the trips that I did was most memorable. We were up in the Arctic Circle. We were up at one of the Air Force early warning radar stations operating there with Sandia National Labs. We're actually looking at particulates in the atmosphere and how they start forming clouds. So actually, you have these little things floating around, and water droplets gather around them, and then they start forming clouds. And so that drives a lot of the local weather systems. So there's very much a big interest in detecting these things beforehand. And so we were out flying unmanned aircraft systems, several kilometers off the coast from this Air Force station. I mean, it's just miles of flat tundra everywhere. It's unique and kind of beautiful in its own way. The 2 weeks we were up there, we saw the sun maybe 13 minutes. It was
Wow.
very unique.
Yeah, that's incredible. So So sun for 13 minutes. So basically you were operating also then all of these flights in the dark?
It wasn't dark. It was kind of like dusk the entire time. I mean, it did make it very easy to see any of the lights on board the aircraft, which was nice.
Okay, that makes sense. And the Arctic, most people don't realize how kind of critically important that area is for national security, the resources there, and then with global warming and some of the ice shelf melting and kind of opening up the way to the Northwest Passage for countries like Russia. It's a really interesting and highly contested area, and so understanding the weather systems there, especially for, as you kind of mentioned, maybe military operations, pretty significant stuff. So that's really cool that you had that opportunity to do it. Um, let's go from ice to fire. Tell us about tell us about your wildfire contributions.
Yeah, so we've worked with NOAA on that one. They produced the S2 is kind of cool in the fact that we can swap in and out payloads. Even before we do a mission, we can take a look, say, all right, these are the payloads we have available. Which one's going to give us the best information, and swap that in for that particular mission. Sorry, excuse me. So the with NOAA, we actually just gave them the specifications for the payloads, the mechanical interface, the electrical interface, and they designed their own payloads for doing wildfire monitoring and improving their models. One was in situ, so it was measuring particulate sizes and ingesting some of that information there. And the other one was a remote sensing platform. So it was looking at many different wavelengths of thermal and infrared and giving a good overall picture of what was going on with the fire itself.
So are they still using this tech then? Because, clearly, I mean, I think it's tamped down just slightly, but, about a month or two ago, literally the world was on fire. And I mean, and certainly our backyard, right, Jack, in Colorado, such an important use case to be able to kind of find hotspots before they really flare out. How's that going right now?
Unfortunately, because of the pandemic and the fact that they're a federal lab, they haven't been able to get out with us and do too many operations. So we're hoping to kind of spin that up starting next year again. So yeah, hasn't been much recently.
Wow. So definitely, I know you're working probably talking to Ben Miller at our Center of Excellence for Aerial Technology Firefighting, at Advanced Technology and Aerial Firefighting. So such a mouthful, his organization here in Rifle, Colorado. But I'm sure there would be huge interest there. And then, of course, Todd Spain with the Advanced Mobility Collective is kicking off the Forest Tech Center. So I see a role for you there, Jack. Let's get those intros going too. That would be pretty spectacular because I know those two have paired up, and that is a dynamic duo right there. It's going to be an amazing thing for the state and for the nation and probably globally. Just a couple minutes left. I want to talk a little bit about GPS denied environments and kind of some of the work you're doing there, and then kind of end with a little bit about some of the recent accolades and kind of where you are with the company. So let's talk GPS denied environments first.
Sure. Yeah. We've talked a little bit about this. It's been in the background of most of the things we've been doing, but sampling these various different things usually requires we fly away from the person that's operating the vehicle itself. And so in order to do those beyond line of sight flights, you have to go through a lot of different rigor to be able to, meet the regulatory requirements and the safety requirements. In fact, for when we're doing it for the volcanoes, as I mentioned before, it took us about 2.5 years to get through all those different paperworks and meetings and things like that.
Wow.
So we're trying to make that simpler. We want to make it so we can go and do routine flights, and some of that requires that you have to achieve a level of safety that you see on manned aviation with unmanned aviation. So a couple of different things that you have on board are the ability of the pilot to kind of navigate themselves should anything else fail. We don't have that on board with an unmanned aircraft system. And so your primary sensor is usually the GPS. GPS is a fairly weak signal, so it can occasionally get blocked, or maybe even the sensor fails itself, so it'd be nice to have a backup. What we're doing is we're combining video, downward-looking video, with what we're calling signals of opportunity. So all the different radio waves that are bouncing around, taking a look at them, figuring out where they're coming from, and using that to figure out where the aircraft is. Combining those two together intelligently, video is great, but it doesn't work in all the weather systems, things like that. And then using that to complement the GPS. So we can take then a look at the GPS signal and say, hey, look, these two don't match up. There's something wrong maybe with the GPS, and then switch over to this other solution to provide something that you can safely navigate back to where you started from.
Very cool. I mean, I think Elsight is doing something similar. They were on the podcast last week, and when you talk about visual learning and kind of visual detect and avoid, that's Iris too. So, I mean, everything all of these your company, their companies are doing are really contributing to the body of knowledge and all the different technological enablers that are going to make beyond visual line of sight a real thing, right, in this country. I mean, we've got the FAA's beyond visual line of sight, ARC happening right now. Hopefully we'll get some recommendations out of that. And who knows, Jack, maybe we'll see some rulemaking next year. And then this will really allow Black Swift to take it off even more. Let's, before we talk about how you're, basically the accolades y'all have received, because we have about maybe 5 minutes left, I want to talk about the most extreme beyond visual line of sight case that you're working on, Venus. So I mean, we talked hurricanes, wildfires, the Arctic, tornadoes, and now Venus. So tell us a little bit about what you're doing, what you're designing there. I think it's with NASA, if I recall correctly, for some flights around Venus.
Yeah, believe it or not, these are all related in one way, and that's that they're all flights through extreme atmospheres. Venus itself is pretty violent as far as the upper atmosphere. The whole air mass basically moves around the planet once every 4 Earth days. And then below the clouds, it's, compared to that, relatively stagnant. So you get these huge gradients around the clouds. And that's generally where they want to do the sampling. And so to date, it's been proposed to use balloons to do this, but we took a look at using gliders to do it. There's a technique called unmanned or dynamic soaring that's used by albatross to go across the ocean without flapping their wings, and various other things that RC pilots have been able to fly these small wingspan aircraft up to 500 miles an hour with.
Wow.
And so it can provide a lot of energy to the aircraft, and you have that great gradient already at Venus. So we developed a very high fidelity simulator with the best of our understanding of what the Venus atmosphere looks like, and designed an aircraft that we were able to show can exist for a month or longer in the atmosphere of Venus.
So we are getting so short. I could talk to you all day long, and also for the next 60 days, like I've been doing, like for the last 30. I want to make sure everybody knows two very important things. Number one, your 10th anniversary is coming up, so congratulations for that, for Black Swift. In fact, for everybody out there, if you're in Colorado, if you're not, you're going to visit around December 3rd. Please know that we'll be celebrating Black Swift's birthday and also the UAS Colorado holiday party all at the same time, due to the generosity of Jack and Black Swift at the Rayback Collective up in Boulder, Friday, December 3rd from 5 to 8. So we do have a meetup out there. If you sign up so we know how many people, we would love to see y'all. It would be amazing. And then you also just came out on this list, right, of the top, one of the top 50 companies to watch in Colorado this year. So huge kudos. Congratulations.
Thanks, appreciate it.
Yeah, absolutely. I mean, no surprise considering everything you're doing and making such a huge difference. So we didn't have a ton of time to talk about all your different platforms, Jack, besides the S2, and I know and all the different sensors that you guys have created and pushed out. Let's leave it at this. How can people learn more about Black Swift, and how can they get in touch with you to learn more as well?
Sure, yeah, we try and keep up, on our social media channels, a lot of the different cool information that's coming out of these things. There's obviously our website, and then, we're just a small company, so feel free to just email and reach out. I'm always happy to answer questions about people have about whatever we're doing. I'm one of the few fully American-made unmanned aircraft systems where we understand every different component of it. So, I mean, if you have an issue with unmanned aircraft systems or want to do something unique, we can probably help you out.
No, that's awesome. And what can you just kind of quickly tell folks what your website is?
Yeah, it's just bst.aero, AERO. Fairly simple.
Okay, bst.aero. Very, very good. And how do they reach you?
They can email me directly just at Elston, ELSTONJ at bst.aero.
Okay, awesome. And before we dial off, do you have any closing comments for the crowd out there?
I mean, hopefully this was entertaining. I really appreciate you taking the time to watch this. So thanks.
Yeah, absolutely. And not only watch this, but keep watching because Black Swift is doing amazing things, and I know there's going to be even bigger things in 2022. I'm so glad to kind of be a part of that journey with you, Jack, as a strategic partner. And thanks for your sponsorship of this episode. Thanks again to Iris Automation, also for sponsoring this entire month of innovation and having folks like Jack on here. In fact, for everybody, real quick, tomorrow, as we kind of round out Innovation Month, we've got John Eberhardt from ATA. They have a really interesting air deck solution at the state and local level where they're scooping up information that might not even be on maps to kind of complete that air picture that's going to be needed for unmanned traffic management. So check out our clubhouse tomorrow. That's 11 a.m. Mountain, and then same time, same place, actually next Wednesday for John. He's going to be an ATA or going to be on this podcast. So hope to see you there. Everybody have a wonderful week. Thank you so much, Jack. This was awesome. Thank you. Out here. Fly safe.